How smart contracts work. Most agreements in the world follow a familiar process. Two people or organizations agree to certain terms. Those terms are written down. And if something goes wrong, someone usually has to step in to enforce the agreement. That might involve lawyers, banks, or other intermediaries. Smart contracts attempt to automate part of that process. Instead of relying on a person or institution to enforce the agreement, the rules are written directly into computer code. Once the conditions are met, the contract executes automatically. No paperwork. No waiting for approval. Just software following instructions. So today we are going to walk through how smart contracts actually work and why they have become such an important idea in blockchain technology. Chapter 1: What a smart contract actually is. Despite the name, a smart contract is not really a contract in the traditional legal sense. It is simply a piece of code stored on a blockchain. This code defines a set of rules and conditions. When those conditions are met, the program automatically performs a specific action. For example, the contract might transfer cryptocurrency from one account to another, or release funds when a certain event occurs. Because the code runs on a blockchain, it operates in a decentralized environment where the rules cannot easily be changed once deployed. Chapter 2: The basic idea behind automation. To understand the concept, imagine a vending machine. You insert money, select a product, and the machine automatically delivers the item if the payment is correct. There is no cashier involved. The rules are built directly into the machine. Smart contracts work in a similar way. Instead of dispensing snacks, they execute digital transactions according to predefined rules. Once the conditions are satisfied, the program performs the action automatically. Chapter 3: Running on a blockchain. Smart contracts are typically deployed on blockchain networks such as Ethereum and others that support programmable transactions. The blockchain acts as the environment where the contract code is stored and executed. Every node in the network maintains a copy of the blockchain. When a smart contract runs, the network verifies the execution to ensure the results are consistent across all participants. This distributed verification helps ensure that the contract behaves exactly as written, without relying on a single central authority. Chapter 4: Writing the contract code. Before a smart contract can run, someone must write the code that defines its rules. This code describes what conditions must be satisfied and what actions should occur when those conditions are met. For example, a simple contract might say that if a payment is received, ownership of a digital asset is transferred to the buyer. Once the code is written, it is uploaded to the blockchain network. At that point, the contract becomes part of the blockchain and can be interacted with by users. Chapter 5: Triggering the contract. Smart contracts do not usually run continuously on their own. Instead, they are triggered by transactions sent to the blockchain. For example, a user might send a request to interact with the contract. The blockchain network then processes that request and executes the contract code. If the conditions in the contract are satisfied, the program performs the specified action. This might involve transferring tokens, updating records, or executing other programmed functions. Chapter 6: Transparency and Immutability. One of the reasons smart contracts attract attention is their transparency. Because they exist on a blockchain, the code and transaction history are typically visible to anyone using the network. Once the contract is deployed, its code usually cannot be altered easily. This characteristic is often described as immutability. It means the rules remain consistent once the contract is active. However, it also means mistakes in the code can be difficult to correct after deployment. Chapter 7: Real-world applications. Smart contracts are used in a variety of blockchain-based systems. In decentralized finance, they help automate lending, trading, and asset management without traditional financial intermediaries. In digital collectibles and gaming, smart contracts can manage ownership of digital items. Some supply chain systems experiment with smart contracts to track goods and automate payments when shipments arrive. In each case, the goal is to replace manual processes with automated code. Chapter 8: Advantages of Smart Contracts. Smart contracts offer several potential advantages. Automation can reduce delays because actions occur immediately once conditions are satisfied. Transparency allows participants to verify how the contract operates. And decentralization reduces reliance on a single authority controlling the process. These features make smart contracts appealing for certain types of digital agreements. Chapter 9: Limitations and Challenges. Despite their potential, smart contracts also have limitations. Writing secure contract code can be complex. Errors in the code can create vulnerabilities. Smart contracts also depend on external data sources when interacting with real-world information. These sources are sometimes called oracles. Ensuring reliable data input remains an ongoing challenge. For these reasons, smart contracts are still evolving as developers improve tools and security practices. To wrap up, smart contracts are programs stored on blockchains that automatically execute actions when specific conditions are met. They function as self-executing agreements written in code. By running on decentralized networks, smart contracts operate without relying on traditional intermediaries. They are used in areas such as decentralized finance, digital assets, and automated transactions. While they offer transparency and efficiency, they also require careful design to avoid errors and security risks. Smart contracts represent an attempt to turn agreements into automated systems. Instead of relying entirely on institutions or manual enforcement, the rules are written into code that executes automatically. Whether they become a major part of future financial systems remains to be seen. But they have already introduced a new way of thinking about how digital agreements might work. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.